Hey, John Fields here today. I was going to make a quick video about testing 6L6s, matching them, making sure that they're functional. What prompted me to make this video was that I was working on a 5150 for Ryan Bruce of the Riffs and Beards channel, and in the process of having his amplifier, while I had it, his studio burned up and all, so I decided to go ahead and do him a solid and match up some really good tubes to put into his amp. So I pulled out my old tube matching setup that I built probably back when I was 23 or 24 years old, and I built it on a Triumph 60 chassis. Basically what I did is I took a 100 volt 60 watt tube amp transformer, so I could get like a 550 volts out of it on the plate, and 60 watt output transformer that would work well for a variety of different tubes, and I just hooked that up into a basic power amp configuration with a 12AT7 driving it, and then a direct input to the power amp so I could look at clipping. I didn't put any feedback on it, so that I could look at it honest on a scope and all. It'll test all those different types of tubes plus 6550s and EL34s, but anyways, I put a 1 ohm cathode resistor in the cathode of each tube, and this is my standard tube, which I have, let's see here, we'll put another Softtech in here for now just to see. It's really hard to do with a camera in your hand. Alright, so anyways, I'll flip it on. So this is a pair of Softtechs that I left in there the last time I tested tubes, probably 10 or 15 years ago, and then I remembered I had this matcher, and I thought, well, I'll pull that out to use to match up some Sylvanias for Ryan's amp. So anyways, the way it works is I have these two bias probes right here. This probe goes to this tube, and I'm just going to use this as my standard tube, and after you let it warm up for about a minute, you can take a pretty decent idle current reading. As you can see, I have this one in there as a standard, what I would consider to be a bogey tube, and it's drawing 36 to 37 milliamps. Now the reason I have it biased hot like that is because this is a test fixture. It's not made to listen to, so I want to make sure I draw some pretty solid current on the tubes when I'm trying to determine if they'll match, because they are more likely to drift at low current. And I also have a pretty high voltage plate on there, about 550 volts like I said, so it's a good test fixture. Not great for sound so much, but the other feature is that you can put an input into it and basically just look at the waveform and see what it's going to do when it clips, and you can see the very little bit of crossover distortion coming in, and it's a really tall long wave, and that's what they look like with no feedback. So anyway, you can also measure the AC current going through the tube in that regard. So that's just the DC current at idle, and this is the DC current at like full power, and then you could also hit your AC button and measure the AC current. Now I'm measuring across a 1 ohm resistor, so I'm on the millivolt scale, and 1 millivolt equals 1 milliamp in this case. Alright, so let's see what this other tube's doing. The standard tube right here is sitting at about 36 or 37 milliamps. This one's sitting at about 45, so it's a really hot tube. Alright, we'll turn the power off, and I'm going to put one of the 6L6 Chinese 6L6s that was in Ryan's amp, and it has a plate current reading out of a test fixture of 35 milliamps. So let's just see how close it comes to that, because I know that Ruby's test fixture is real similar to this. So we'll let it sit there for about 1 minute, and we can, if the tube's good, we can watch the current come up slowly as the tube warms up. Alright. And you don't have to let it go for a solid minute, but it's important to let it at least get to like a thermal equilibrium inside. When it's stable, you'll kind of know, and you can see it's kind of settling right there, right around it's going to be between 34 and 36 milliamps after another minute or so. So Just as a quick test, we'll call that 35, just like it says on the side of the tube. Now let's go ahead and, since that was out of a match set, let's go ahead and pop in another tube out of that match set and see what it says. And I can test them up against this standard tube because it's going to draw its plate current based on the output transformer and the load, not so much the other tube. So it doesn't matter what you test it against. You're going to measure the plate current of that tube in a situation with a particular grid bias and plate voltage on it. So putting that one in, we're going to let it turn up a little bit. Oh, and if you're wondering what this little red thing is right here on my bench, stop thinking like that. It's a silicone deal that's made to grab EL84 and 12AX7 tubes when they're hot. It won't fit. So I mean, basically, I had one question about that earlier, but let's see. So this one's coming up pretty fast, and I don't believe it's going to get to the 35 milliamps that's basically claimed on the side of that tube. So we can basically call BS on the match for this particular set of tubes, which I found the case. I found to be the case with other sets of Ruby tubes. Not so much recently. I haven't really seen very many tubes out of the Shigang factory since they've relocated. But anyways, that's the second one out of the bunch right there, and it's sitting around 30, even though it says 35 on it. And we'll just go and check the other two out of that set. Key. Okay. And I forgot to turn it off, but I'll be honest with you, it really doesn't matter. When you're testing a tube, you want to know if the tube's going to be good and reliable, so it's not necessarily the end of the world if you do some bad stuff to it. But now in the case of really valuable tubes, new old stock tubes, it's always better to be safe. But in the case of the next tubes that we're going to test, it's not as important because even though they're vintage and old, they're really super robust tubes. And I'm talking about the Sylvania STR387. It's the 6L6GC that PV and Fender and a lot of other brands used. And this is an old shipping box for 6L6GCs from PV that I got back when I was in high school. They donated several boxes of these to our electronics class because they didn't have PV screened on them. They had Sylvania screened on them. And anyways, they used several of them for Christmas tree ornaments. And of course some of these have busted pins, but after they came back from the Christmas tree in the local mall that they were hanging on, I went and got them out of the dumpster and desoldered all the wires off of them and went and found as many of these boxes as I could and put them back in there and hung on to them. So I still have, about a box left, and over the years I've used an awful lot of them for things. But anyways, this third 6L6 out of the set is sitting around 32, 33. So anyways, as you can see, the matched Ruby 6L6GC MSTR set is not matched, but it's a good set of tubes. It's fine. Your tubes really don't need to be within 3 to 5 milliamps of each other for you to consider it to be a good match, because they're going to drift, and when they do, you're not going to hear the difference. The amp's probably going to sound better as the tubes age, and then when they get to a certain point, if they're biased hot enough, they'll eventually start to fail. And if you keep the heater voltage normal, and don't overbias the tubes, they generally last a really long time. In the case of the Sylvanias, they'll last practically forever as far as I can tell. I've seen very few bad ones unless they were mechanically damaged. Okay, so this tube also says 35 on it. It's been sitting there about a minute, so we can deduce that it's going to be 32, 33 like the other one was. So basically there's a decent set of tubes, but it's wasn't matched. And so I'm going to box these back up and send them to Ryan for backups after I get the good ones in there. So I have a few, there's some other random tubes in here, but let's just, let's grab, here's one, here's a green label that was tested at some point, as evidenced by the scratches, and it may have even been used in an amp. But like I said, these tubes don't generally age, so let's just see what this one measures up against all the other ones that we've done so far. And that's a genuine Sylvania STR387. These scratches are from the little metal tube ring clip thing that PV put on there, so obviously that was in a PV amp at some point. Okay, and the plate current's coming up here, and I'm gonna assume this is probably a good tube. And wow. And you'll notice that the Sylvanias, they vary a lot when you match a big batch of them. I used to notice that they generally fall in they'd be slightly lower than bogey tubes in most cases when you put them in a fixture like this. And here you see the same thing. This one is saying it's around 33, that's good enough. I'll take that. And so we'll say this is a 33. And now let's grab another one here. There's a nice one. STR387, made in USA. Now that little code right there is a date code and lot number. I can't really remember what the date is on these. I think it was 84, 85. Whenever they ran the last run of them, they had the green labels on them. And those tubes had what I would refer to as an infinite vacuum, and that's why they rarely fail. And they can also handle a substantial amount of screen current compared to other 6L6s. So the PV amps that had a 100 ohm screen resistor didn't really suffer from that being the case. 'Cause then some of the modern 6L6s really don't do well unless the screen is limited quite a bit. Okay, now let's see. This one's coming up pretty fast. And these tubes didn't always come out the same, but it was real easy to find a match from what I remember in testing them before. And this one's looking like it's going to hit around 33, 34. When you see it jump back down like that, you can pretty much say it's going to quit. So that's a good. Let's just look at the signal real quick with that soft tick in there with it for a second and see. Beautiful. That little click on the waveform right there is not the amp. That's actually a problem with the signal generator. I got a dirty pot. If I pull on it, it works fine, but it just puts out good solid power. You know, the clipping waveform on the top is indicative of what the STR387s do with the little goob on it. I'm not really sure why. But anyway, so we have two that are sitting right around 33. All right, and let's see what else we got here. There's another one. These are dirty. I'm gonna have to clean them up, but I like the ones with the green on the bases because you can wipe the glass off and not rub off the Sylvania logo, which is pretty good. Now that green ink is also heat sensitive, and it'll change colors when the tube gets into an overbias situation for too long. And you rarely see that happen with these unless there's a mechanical failure, like I said. Okay, so here's our third one, and odd. Now it jumped up to like some extreme high current right there for a second. So I'm thinking this tube may be going into thermal runaway. Let's watch that happen. Look at that red plate coming up right there. This is a bad Sylvania STR387. Now eventually it'll pop my fuse because it's going into some severe thermal runaway. So I'm just going to say no, turn that one off. And like I said, you know, going through a big batch of these coil tubes like this, you're likely to find a bad one. So I'll mark that one bad. Let's see what else we got here. Now here's one with it labeled on the glass, and it's missing the base pin. We don't want to put that one in there. A couple of them missing the base pin. Here's one labeled on the glass that's not missing the base pin. Let's see, and let's just see. And this is a wonderful exercise in testing old tubes out of a box. If you ever run across a box, it's a pretty cool thing. you'll want to be able to test them. So let's just see what we have here. All right. This one's acting a little more normal. It's quite a bit on the colder side compared to the other two that we had that were good. So we can say it's probably going to hit around 28. And like I said earlier, that's within 5, so I wouldn't have a problem using that in a match set with two others that measure 32, 33. So we'll just kind of put that one here. We'll remember that it was 27 and 28. I should be writing all this down, but I'm actually waiting to sell a car this morning, so I just thought I'd pop in here and knock this out while I was waiting on the guy. Alright, let's see. Another one labeled on the glass. So far, nothing. Now, this may also be a bad tube. And since I'm pulling these out of a coal pile, I'm definitely going to go back and verify the set in an amplifier, listen to it really well, burn it in the amplifier. That'll be the last part of Ryan's repair, will be the burn in. And after I'm sure that the amp's 100%, I can put it back together and stick it in the mail. Okay, we're going to say that this tube here is open in some way because it's not appearing to draw any current. So, and the plate current is what we're measuring here. Let's check this guy out. It's labeled on the base like the other ones, and it'd make a nice third tube in the set. Let's see. Nice. Okay, this looks like I could have a set of tubes that were reasonably matched, if, you know, not perfectly. But here's one thing I'll say, since that other one measured about 27, 28, this one's going to hit around 30, the other two are around 33. That's okay. That's a decent match. Since this one's actually a little closer to the first two, though, I'm gonna, and it also cosmetically matches the other two, I'm gonna put it in there as a sure thing for the third, and I'll check another one to see if I can get it just a little better. And there's another one with the green on the base, and we're gonna pop that sucker in there. All right, flip it on, and if this one comes out, you know, between 30 and 35, we'll call it a day. If not, we'll probably put the 28 in there and say that we got a pretty good set of vintage Sylvania STR387s for Ryan Bruce. And really had a lot of fun with this. I just haven't been able to do it as quickly as I wanted to because we got a baby shower coming up and all this other stuff. So okay, this one's going to hit around 37, so it's hotter than we like. Let's see if we can find another one right quick. But I can always go with that 27 fourth tube. We'd be just fine. I'd really like to get one that matches in that set, though. There she is. All right. 27, 37. All right. Nope. Yeah. Another thermal runaway tube. Let's watch the plate get red. I'm really going to have to go through these good. There it is. Look at that. Sucker's starting to glow. Oh, no. Okay, we're going to turn that off. This is going a little too far. Having too much fun in the morning here. All right, put that over in the thermal runaway pile. Let me try a couple of the other American ones. Here's the yellow. This one used to have a yellow PV on it before. This is one of the ones that I originally found when I was looking. Let's see if it comes out between 30 and 35. Even though this is a very boring video and we're watching a meter increase, it's kind of satisfying for some reason. I can't really explain why. I hadn't done this in a really long time and it's really fun. Thanks for coming to watch. 33, 34, we're good. We're going to use that one as the fourth tube in our set. Let's look at the waveform real quick. Just kind of make sure that it's a normal denormal. Absolutely. See that little gap on the top I was telling you about? Something interesting is if you, well, shoot. I'm going to clean that pot before I do my next video. Anyways, we have a nice little match set of STR387s for Ryan Bruce's amp. We're going to finish that up tonight. And there they go. Anyways, thanks for coming in here to watch us again, and we'll see you next time.